Welcome, everyone. I'm Joseph Guillaume. I'm Program Leader for Foresight and Decisions in One Basin CRC. I'm really excited to have you all here. This is a topic that I'm very passionate about. I'm passionate about continuous innovation, about anything to do with how we envisage the future, and also about the future of water delivery in particular. And so today, we're going to have a bit of a webinar first, a little bit of context, and then the panel discussion. And before we start, I do want to acknowledge and pay my respect to the traditional owners of the Murray-Darling Basin and their nations. And we pay respect to their elders, past, present, and future. We recognise that as first scientists, they do have this deep understanding of the landscape and water in the landscape. And in all we do, we are operating on their lands, in their rivers. So I'd invite you to acknowledge the traditional owners of your location in the chat. I'll start by saying a bit about the One Basin CRC. The One Basin CRC is an industry and research collaboration aiming to solve significant and complex water-related challenges in the Murray-Darling Basin. Together with our 85 partner organisations from around Australia, we aim to achieve a more productive, resilient and sustainable Murray-Darling Basin and beyond. We envisage a resilient and sustainable Murray-Darling Basin powered by a strong innovation capacity, which is very important to our topic today, that supports basin communities, businesses, industries, water managers to adapt and thrive with changing global drivers. We have three research programs looking at foresight and decisions, technology and opportunity, and adaptation and innovation. To some extent, our presentation today will actually cover elements of all three. Foresight and Decisions program helps government, industry and communities prepare for a different future by building our understanding of what the future could look like, providing information, tools and resources required by agribusiness, communities and governments to manage climate and water-related risks in particular. The Technology and Opportunity program will grow and diversify water sources and optimize the treatment, storage, delivery and use of water by developing both on and off-farm digital infrastructure. And the Adaptation and Innovation program co-designs services and strategies to support successful adaptation of farm enterprise and rural communities in the context of a changing basin. So within these programs, we have a number of challenges, looking at building capacity to confront climate change together, creating value from digital technologies to support the irrigated agriculture sector, enhancing the water supply system to deliver for multiple uses, and realising value from and within rural industries and communities. So where this presentation today is focused is really on that third one, on enhancing water supply system to deliver for multiple uses, but also drawing on elements of that, creating value from digital technologies and building capacity to confront climate change together. The One Basin CRC, a key part is our 4 regional hubs that are strategically located across the Murray-Darling Basin and act as focal points for place-based research and development and associated demonstration, evaluation, adaptation, and education and training activities. So the work so far that I'll be talking about is focused around our Griffith hub in the Murrumbidgee in particular, but there's efforts in progress that will broaden this further and also come up in a panel. So now I'd like to ask our panelists to introduce themselves. I'll go first. In addition to being the program leader for Foresight and Decisions in the One Basin CRC, I'm a research fellow in the Institute for Water Futures and the Fenner School of Environment and Society. My background's in integrated assessment, uncertainty management in decision support with a particular focus on water resources. Serena, would you like to introduce yourself?
Yes, thanks, Joseph. So I'm Serena Hamilton. I'm a researcher also from the Institute for Water Futures at the Australian National University. So my research over the years has primarily been around the development and use of model-based tools that help managers make informed decisions about complex problems, including those related to managing water resources. I'm also a project leader for the One Basin project on reducing uncertainties and enabling multiple benefits in water system operations, or the Multiple Benefits Project for short. Thanks.
Thanks, Sri. And Sam?
Hi, everyone. I'm Sami Nawandra. I work for Murrumbidgee Irrigation. My title is the Manager for Innovations and Strategic Partnerships here at MI. I've been very fortunate to have had a role to play in sort of developing and scaling a lot of our cool and innovative approaches to utility and network management. And my background is I'm actually a mechanical engineer, came out of the consulting world, spent some time in hydroelectricity, and then found myself in network irrigation. My involvement with the One Basin is I'm deputy project leader for the two QuickStart projects, and also the deputy project leader for the multiple benefits project that Serena's leading.
Thank you very much, Sam. So before we get into the next part, thank you to everybody who filled in the pre-poll quiz. We had a few questions there to get you thinking about how your experience relates to what we'll be talking about today. You can see in terms of what sector people are from, that there is a strong focus on the commercial, consulting, government policy planning, but also quite a good variety with other sectors as well. So the second question around how does or would your organization access new data science or analysis tools, and really thinking about how does that change actually work. And so this is partly what we'd expect, right? Spreadsheets are a very powerful, flexible tool that provides that kind of infinite canvas. So of course, we've got 60% that do use this within their organizations. And as we'd expect, quite a lot in the other categories as well. So buying new software, 27%, 25% receiving updates from a supplier, if you've got that kind of platform arrangement. Developing tools in-house is something that's very flexible. You have a lot of control over, and so it makes sense to have a large number there. Actually, surprisingly low number in commissioning consultants to deliver tools. And it's great to see that there is a substantial number who are kind of already on board with the kind of thing that we're talking about here around continuous integration of new capabilities. So really value questions as we go through around sharing your own experiences, as well as simply asking of the panel what their experiences are. So in terms of the next question was around, does your organization's innovation processes make the most of research relationships? Obviously, from a One Basin CRC perspective, we strongly believe in those partnerships, making sure that we've got strong relationships between research and end users. And here again, quite an even split, actually, quite a broad range of those who already feel they're already doing everything they can about right, or don't have any research relationships at all. So hopefully this will be an opportunity to share knowledge in this space, to start a conversation around that too. And so the key question around continuous innovation is also about speed or cadence of adoption of new data science tools. And so this idea of, are we actually adopting tools fast enough? And again, quite a decent spread around the already doing everything we can, still at 15%. And as we'd expect, some around the change is not well managed and could be faster. There's always some circumstances where we can still do better from that point of view. And a surprisingly low number that say we simply don't use new tools at all. I think this is a space that we're all facing of trying to make better use of the tools that we have available. But thank you very much for filling out the pre-poll, and Joel for sharing the results there. And so what I want to lay out as a scene to begin with is the idea of cyber physical systems across the water cycle. If we're talking about data science, we're really situating data in many different forms. We've got the sensing element where we're getting new data in, the data management and processing, decision-making and control, and then learning, both in terms of community learning and machine learning in that process. And so as you can see from this review article, we really are talking about things that apply across the water cycle. It's not specifically about the context that we've been focusing on in the One Basin CRC, or we'll focus today. And I think that's also an opportunity for that cross-fertilization as well, to think about what can we learn from other application areas. So in our particular context, we'll be talking about water delivery, and I'm thinking here as a model case, thinking about the Murrumbidgee River. It's a system in which it takes 7 days to deliver water down to the big irrigation districts, but irrigators can order or change their orders on a 2-hour notice. So there needs to anticipate what water is going to be used before. We've got the need to deliver environmental water, the in-stream flows, the freshers, making sure that we're taking care of water quality, and the flow and effects of that, of making sure that we do have thriving fish populations and wetlands, and that we're enabling uses of water for cultural and recreational purposes as well. We also, as part of that, think about swimming, water levels for water sport, and so on. It can take a wide variety of forms. Demand for any particular sector is dependent on weather, crop conditions, market conditions, the broader climate and water prices. And we've got a whole lot of tools at our disposal to control where water flows, and also to think about or to predict where water is going to be in the landscape, weirs, gates to control things, storages. We've got also the ability to predict inflows and think about the role of changes in land use practices, both in terms of the impact it has on water delivery and how it can actually help and support water delivery. And all this tied in also to remote sensing, that ultimately we are in a situation where we have an abundance of data that we're not yet fully utilizing. So as the pre-poll already indicated, when I talk about water delivery data science, I'm primarily thinking about that analysis of data and its use in decision making, but there's a wide variety of ways in which we can actually make use of this. And so the context in which we want to operate is one of continuous innovation, where we're capitalizing on new data, new opportunities to better track evolution of the system and improve performance. We want to build a knowledge system that ensures that knowledge is updated over time and available when a decision needs to be made. And so you'll see a couple of these feedback loops that I've built in here. So here's one where we're thinking about, well, what do we know already about the system? What would we like to know? Who can do what to get us there? Recognizing that it's not about just an individual or just one organization, but there's often potential for collaboration to actually realize this vision of getting this new piece of knowledge, new piece of data, new piece of decision-making support that we can leverage. And so this question of how do we resource it actually can be one that comes later. We've talked a bit about this context of digital data in irrigation as part of a podcast as well that I invite you to check out if you're interested. So in the context of water delivery, I want to go one step deeper into this. To begin with, the primary way that we deal with uncertainty in water delivery is the idea of having a human in the loop. And so again, one of these feedback loops, that if we have a situation where we've got sensing and feedback of new data coming in, we've got then this partnership between the human and the machine prediction, that the machine prediction is often not going to be used directly for automation. Instead, it's going to be processed by some kind of human decision who takes responsibility, who's able to check what the strengths and weaknesses are of the machine prediction, and who's able to adapt over time. And as part of that, also being able to evaluate the performance of both what their decisions are, but also the strengths and weaknesses of the machine predictions that are available at a particular time. And so what we've got in this loop here is then this question around evaluating performance. And what I'm suggesting, and apparently a third of the audience is already kind of on board with this, there's a natural fit with use of continuous integration practices as part of this. So the idea that we're able to test performance of new algorithms before they're actually adopted, but to do that again in a feedback loop, that we're evaluating needs, planning specific investment, developing a new solution, testing that performance and releasing it. And ideally, we want to do this in a relatively rapid way in order to keep adopting new capabilities as soon as possible. And so to go a little bit deeper further, we can talk about the idea of a tech accelerator in order to get that speed. And so what we're proposing as part of this work and what we're trying to build is this idea of a tech accelerator that consists of clear and agreed procedures, infrastructure, and relationships to help test new ideas quickly. So part of that is access to real-world data, that algorithms are not developed for ideal conditions, but are actually developed on the conditions that we're expecting from the very start as part of these collaborations. We want well-defined assessment frameworks. So for any particular algorithm, understanding what does success actually look like at this point in time, given where we are now and where we want to be in future. Part of this is about building this shared understanding that people using it, the people in the human in the loop, have an understanding of what the operations needs to be. And the people who are developing these tools and testing the tools and so on have a clear understanding of what it is the operations needs as well. It's also about providing clear pathways to implementation, that we don't want to be in a situation that we've spent a whole lot of time developing a tool and we don't actually know how it would even fit within the existing systems. So a well-defined assessment framework is having that clear to begin with, to know this is the spot within those frameworks that's going to change to incorporate our new tool. As part of this, we do want efficient onboarding. We don't want people developing new tools without the right context. And again, with this feedback loop, we want continuous improvement of the assessment frameworks. We don't want the pie-in-the-sky, perfect Rolls-Royce assessment framework up front necessarily that people look at and go, well, we can't achieve that at all. It's just unrealistic. We instead want to tie it closely with what the human in the loop is actually doing and thinking about incrementally adjusting the complexity of that assessment framework so that we have that shared understanding and clear pathways to implementation evolve over time. And so obviously part of this is around change management from a systems perspective, because we're trying to continuously change as we do this. So the context in which we're primarily operating here, we've conceptualized following previous work as well as being a kind of two-level adoption process. So we've got a managerial intervention that gives the green light, I suppose, that the algorithms should be adopted. But we also have a secondary adoption that the operator themselves have to actually use this data. It's not enough for it to be present in a platform or present as a tool. It actually needs to be of use directly. And so when I talk about the tech accelerator and continuous integration, I'm certainly not suggesting it as a magic bullet. On the contrary, for many organizations, it requires a transformation of how they're currently operating to start to formalize a lot of the things that they're doing informally otherwise. And so we can think about it in terms of a tech accelerator as a bridge between organizations and providers of solutions, where the providers of solutions are onboarded. There's a low barrier to experimentation. There's potential not just for product sales and consultants to deliver things, but also research, thinking about how we maximize the use of internships, undergraduates, honors, masters, PhD projects, as well as competitive grants, to really be able to look at the wide variety of possible innovation, that it's not just about things that are ready to go as a product, but also about providing a context in which we can rapidly test ideas that have just come up in a hackathon or that are only half developed, and we just want to be able to test it as soon as possible. And so the clear thing here is that we do want to be able to meet clear assessment requirements. We don't want all of this innovation happening in a vacuum. We want to connect it through. And so that's where on the other side, we have the organization having these agreed clear procedures, infrastructure, and relationships on which they're relying. And the tech accelerator as an intermediary here in terms of providing licensed data extracts for use, the infrastructure needed for software testing and continuous integration, the training needed to make sure that everybody is onboarded and on the same page, the community development as well, of reaching that critical mass of people working on common problems to be able to achieve new ideas, and the continuous improvement processes around this as well, that it's not just a set and forget to just create a framework and leave it at that. So the two examples I'll briefly be talking through, I think about this in terms of different data science product classes. We've got a product class where we think about anomaly detection and one around demand forecasting. There are obviously many others. On the anomaly detection side, the kind of thing that we tend to aim for is SCADA alarms, that when the alarm goes off, we know that there's an issue that has to be actioned in a particular way, and we can just go for it. In reality, and what we've found is that in our work as well, is that not all tools are ready to be used directly as SCADA alarms. And so we've got to think also about more complex alarms that are then used as part of other processes to prioritize further tests and so on. Fault analysis tools to understand why a fault has happened and to address the root cause. And also the failure data collection tools. That a lot of this work from a data science perspective requires well-validated data that we can build on. And on the demand forecasting side, I'll be focusing primarily on the river ordering problem, but I'll say a little bit more about the broader context afterwards as well. So the context in which we're working with is firstly in terms of gravity-fed irrigation systems. But as you can imagine from what I described before, the general principles are intended to be more transferable than that. So we've got a channel that has gates at each end that define a pool that controls the water level. Each of these gates manages the flow, and we've got a water balance happening through this as well. So our first project that I'll mention is looking at anomaly detection for high reliability water delivery. And so the idea here is that we know that things fail. That's just how the world works. And in order to work in extreme circumstances, in extreme drought or flood, or when there's a very high demand, what we want is a high reliability system. We want to be able to deliver water exactly where we want it in the landscape, exactly how we want it at any point in time. And to do that, knowing that all of our systems are prone to failure at some point. And so we want the tools to be able to manage this. And so the project has trialed processes for co-designing and operationalizing new tools to help detect these anomalies in water delivery infrastructure. So the benefits around improving reliability, reducing maintenance costs, and also improving data quality, that we know that the data that's come in is actually quality assured, and we can build our further data science tools on top of that. We've focused especially on prototype tools targeting water level sensors and batteries, and also as part of the same project, building an understanding of how these tools fit within the broader failure mode analysis and what deploying these tools would involve in practice within these particular organizations. And I'd like to acknowledge here the collaboration with between ANU, Colliamberley Irrigation, Murrumbidgee Irrigation, University of Melbourne, and Rubicon. And so the fundamental building block here, if we think about the gates that are controlling the flows within these gravity-fed systems, there's a number of components all controlling, all coming together to achieve this outcome. We've got the control door that controls the water level and flow rate, and it's informed by a flow and level sensor with a local control system, which provides information back to base, as well as instructions. And there's obviously a local interface as well for manual interaction with the assets. The control door itself is obviously set within a door frame concrete structure. It has an output drive system that's controlling its position. And all of this has to be powered with a solar drive board, in this case with the solar panel and battery bank. So this is a fairly general conceptualization of the system, but I acknowledge that it's based on Rubicon's products in particular. And so just to give a little bit of a feel, so the key idea here is that we weren't aiming to solve all problems at once. What we wanted to do was to set this process of continuous innovation in this space into action, and to make progress where there's greatest marginal advantage at any point in time. So on the left here, at the top left, what we've got is a context in which we actually have two water level sensors within the same pool. And it's possible for a variety of reasons that they end up not agreeing. So that's what we're seeing here. The two sensors are giving different information. And in this case, what we're looking at is potential for blockages of the water level sensor. How can we tell that it's there and action it as early as possible? And so very simple algorithms here, looking at the difference between these and then triggering a threshold that actually then raises an alarm. Slightly different, but in the same ballpark on the right, what we've got here is battery voltage, and we can see that there's an anomaly that occurs that the battery voltage changes, which indicates it's an issue with the battery that needs to be followed up. And so here, using quite standard methods around Q-sum algorithms used in the industry to then trigger this alarm when that cumulative error has actually gone too far. So if we think about the assessment here, we're interested in the frequency of these alarms, that we don't want alarm flood, about the frequency of false positives. We also want to be able to then manage that with tunable thresholds. And so these are strengths of both of these methods, that we are able to tune the threshold in ways that manages the false positives in absence of having improvements in the data science to actually reduce the false positives as well. Remembering also that we had those other ways to use these anomaly detection tools, that if we have a particular data science tool that isn't yet up to scratch to provide that high reliability scatter alarm that has to be actioned immediately, there's other ways we might still be able to use it. And one that jumped out in this context is around the need for high quality validation data. That at the moment, we don't have the data needed to be able to evaluate at scale how well do these algorithms perform in terms of their false positive rate. And in order to do that, we've got to actually code the existing data to get that background. And so these tools can help identify candidates that can then be manually classified. The second project I want to talk about is around demand forecasting and water delivery operations. And again, recognizing the collaboration with Colliamble Irrigation, Murrumbidgee Irrigation, University of Melbourne, and Australian National University. And so what we're looking here is looking at how new demand forecasting tools can improve water delivery across the landscape. Testing in particular how demand water forecasting can support river watering and the role that demand forecasts play in water operations. And so here we deliberately took an approach of testing more than one different model, again, with that mindset that what we're trying to set in place is continuous innovation of future demand forecasts. We started with one that we were relatively certain would perform well, where it's predicting simply the total demand at the offtake on the river, aggregating across all of the farmers. So clearly we will be able to do better in terms of accuracy over time by bringing in more sources of information, breaking down different customer behavior groups and so on, thinking about what the different crops are doing, thinking about what's happening in different zones. This is all part of what can be achieved with continuous innovation over time. And what we want to do is to simply start somewhere that is already useful. So we have a model that uses crop data and weather data, goes into a conceptual module based on crop irrigation requirements. And then it's a hybrid model that then has a data-driven module that predicts the residuals as well of the system based on a number of data-based inputs to produce 7-day forecasts as well as forecasts at other lead intervals. And so if we think about how we evaluate river watering demand forecasts here, we do want on the one hand to think about the different classes of metrics. We've got the basic quantitative metrics, also ones that are more risk or control informed, thinking about the impact of errors in demand, and also diagnostic metrics of being able to identify why is it that a forecast is failing in any particular circumstance. Noting that as soon as we get into those more risk or controlled informed forecasts, we're also talking about things that are potentially more commercially sensitive. And so we've got to think about what information is shared with whom as well. And if we stopped at river watering and demand forecasts, there is a risk that we'd end up over-investing in improvement, continuous innovation in this particular space, and that we'd miss opportunities to improve our treatment of broader business risks. So the part of the assessment context here is to think about ability to meet demand needs of customers across the short term, thinking about the role of surge reservoirs, adjusting orders, anticipation of changes in river conditions as other ways in which our risks are actually addressed. How do we manage flexibility, recognizing that we actually expect our forecast to shift, that the 7-day forecast probably won't be the same as 6-day and so on. Thinking also about the relative value of demand forecast across conditions. It's higher when supply is constrained. And so there's potential for loss, storage, asset failure forecast to be built into this process as part of things that we'd want to innovate on as well. And so more broadly, thinking about evaluating delivery, reliability, performance, and how that all comes together, building in the water storage, water level management across zones with consideration of constraints as well. So this is an example of where, yes, we can evaluate the forecast by itself, but we also want to think about evaluating the broader assessment context and to do that over time rather than jumping to a full assessment framework to begin with. So I just want to broaden out a little bit more. The project also looked at where could demand forecasting fit across the landscape. And so here you can see exploration around how it fits in terms of operational, tactical, strategic levels, farm, irrigation, district, catchment, and regional, and also the different uncertainty levels that are being tackled. This is again thinking about within that particular place-based context, what is the range of different ways in which we could actually invest in improvement in demand forecasting? And so I think this is nearly the last slide. This idea that different applications then have different levels of complexity as well, based on how many actors are in, how clearly defined the problem, solution, and goals are. And so the One Basin CRC in particular, because of its partnership, is well placed to try to tackle these more complex ones that would not actually be easy to manage otherwise. Well, I shouldn't use the word easy anyway, but we're better placed to actually make progress on problems that are not tractable when a single organization actually tries to tackle them. And so just to finish, a reminder of that context of thinking about that continuous innovation in water delivery that integrates that human in the loop, continuous integration processes, and the potential for building tech accelerator that enables this. So I'd encourage you to put any questions in the question and answer button, and I'll invite my panelists to come back to the table. Okay, thank you very much. Just to get things started, I might ask a first question to both of you, and then we'll have a look at what's in the chat, in the Q&A. So starting off with you, Sam. So the question I want to ask is, well, what does continuous innovation mean in your context?
Yeah, thank you, Joseph. So, MI's Murrumbidgee Irrigation's mission is quite clear. It's delivering water in the best way possible. So, that's central to how I answer this question. So, when you think about continuous innovation, it's about relentlessly asking questions and really trying to find improvement pathways in the way we deliver water and provide for our customers' needs. You're also trying to use all your creativity that you have, because you think about innovation. Innovation is about two things: asking lots of questions and being creative. So we use all our creativity to try to channel that towards, okay, how can we do this better? And never stopping to do that, because whilst you may think that it's a linear process, it's not, and the gains just keep coming if you keep approaching it in a fairly disciplined way. So continuous innovation in that context for us is about how do we fulfill our core mission in better and better ways to support our customers.
Thanks, Sam. Over to you, Serena. So the same question of what does continuous innovation mean in your context?
Okay, thanks, Joseph. Well, firstly, giving a bit of background about the project that I'm working on. So the Multiple Benefits Project is about aiming to improve information systems and processes that underpin the decisions around water deliveries in the Murray-Darling Basin. That's to reduce the uncertainties faced by water system operators and to enable multiple environmental, cultural, social and economic benefits. So just as those QuickStart projects, where we aren't just concerned about the data and the models, but perhaps equally or more importantly about the people and the procedures linked to those tools and the institutional and socio-environmental context in which they operate. So we're working with several industry partners, and the research will examine the governance, institutional arrangements and the operational decision-making space around those deliveries and develop prototype tools for supporting the evaluation and implementation of delivery strategies. So our project involves 6 formal partners. So that includes the Murray-Darling Basin Authority, Murrumbidgee Irrigation and Water Technology, and 3 universities, so ANU, University of Melbourne and University of Adelaide. So as well as about 10 or so other affiliate partners, so which include water system operators, community groups, consultancies and state agencies. So working across such several organisations has created this incredible opportunity for the cross-fertilisation of ideas. So collectively we have a huge amount of experience and expertise, and we also have a very broad range of perspectives. So many of the organisations and people within have faced similar challenges or problems. So I'll just go back. The project has only recently just started. So in terms of tackling these problems, the people within them have already started trying to tackle them in different degrees and probably in different contexts. But this project has created this collaborative space for us to share how we've approached the problem, what worked, what didn't work. So we aren't starting from scratch. We're sharing ideas and learning from each other to tackle these key gaps in our knowledge. And so having multiple organisations and people involved means we're better aware of current and past efforts in understanding water system operations and water management, as well as that modelling space. And so we're avoiding both making the same mistakes as others have made in the past and also avoiding reinventing the wheel. So, and rather we're trying to leverage those efforts and hopefully create real innovation and impact.
Thanks, Serena. I'm really excited about this project. I think it pulls together a lot of the things we've started on with QuickStart, and there's a lot of vision forward in terms of what's achievable. There's a couple of questions that are kind of related to how the tech accelerator would work, what the continuous innovation would look like in practice. I might ask Sam to begin with. Could you say a bit about what started MI on your continuous innovation process?
Yeah, so for everyone, Joseph gave me a bit of homework before this webinar. So look, essentially, MI has been on a modernization journey of its infrastructure. So roughly, we're a decade in. Our network is nearly fully automated. What that means is you could be a customer at the end of our system, put in an order via an app, and the whole system will cascade and deliver the water to you. It's actually a really cool thing when you think about it, because you could be 200-300 kilometers away from the offtake at the river. So that's very cool. So we had all of this automation that was in the ground, and we actually then started saying, well, okay, we've got all this automation. The automation is kind of is delivering on its primary functionality. And we thought, okay, hey, what else can we do with it? And this is that example of that relentless questioning and creativity, right? So so we started looking, and then we were quite surprised at how much you could actually leverage this information for. The other thing that we did, I mean, and if you think about what's actually going back to the question, if you think about what started the journey for us, it was that realization that, wait a minute, beyond the intended use of the technology, there's actually other things that we could use this for. So that really started us on our journey, plus the fact that we had enough density of instrumentation to have a meaningful impact at some real world problems.
That's great. It is an advantage to have that kind of initial context to kind of push things forward. There's a question in the chat, in the Q&A, around what is the initial cost to set up this data-driven tool from costs without this, say, routine infrastructure system. So what's the advantage, I suppose, of this broader context? I might give my initial reaction to that and see if Sam wants to add anything. So far, the way that we've approached things is actually focusing on the procedures and relationships first and infrastructure second. If you've got the right people with the right skills, it's not about investing a whole lot of money in developing infrastructure to begin with, but it's more about setting things in motion in the right, with the right mindset in the right way. And so there's obviously free tools that can be used as part of this, thinking about, for example, GitHub and the version control tools in that context. But organizations are often they already have relationships with their suppliers to be able to then have conversations around that of what is the best way to start on this journey, leveraging the existing tools that are already there. So I don't know, Sam, if you wanted to comment a little bit more on that infrastructure side.
Yeah, and yeah, absolutely. Look, I can pull on a couple of examples. The from a Maribyrnong irrigation perspective, we had operational systems, as I mentioned, as a function of needing automation worked because the tools actually facilitated automation working. We just realized, hey, we can actually co-opt some of the platform to support this other so innovation works. And the key thing as well, I'd like to mention is you don't want to get it's held up on the whole, we need a platform to do this, right? If you look at what you have at your disposal as a bunch of puzzle pieces, then really it becomes a permutations combinations problem. So you can kind of say, well, this is the problem I'm trying to solve. How might I actually prove or disprove or support that? So you can start with the relatively little, or you can start to get runs on the board and then kind of then have a more deeper discussion on what you need to scale it. Obviously, what works in the start won't work towards the end. The other example I can give you from hydroelectricity and electricity generation is that you actually everyone's got these really complex and sophisticated sort of instrumentation, trending, and analysis tools. And there's a bunch of startups that make plugins to these tools that actually allow you to spin up sort of simple algorithms, simple sort of correlation type algorithms, and they're relying on you as the subject matter expert to know that there's a causal relationship between a few variables. But if you think about tools in that context, you depending on your circumstance situation, you can actually start with something fairly simple and then scale from there. The other thing I'd like to add is that works if you also prioritize for speed. So in your quest to build this thing, so if you move really quickly and with what you have, you can actually build really well.
Thanks, Sam. We've got another question around, can you get access to more information about the tools developed, other tools developed open source? So we don't have links at the moment. The final reports are being finalized at the moment. The tools being developed, the code will be open source as well. But what I'd emphasize here is that these tools that I've talked about are actually not complex. It's often based on things that are already in public literature that are actually able to be implemented fairly easily. So there's not even necessarily the IP complications around it. What we're really talking about here is how do you actually integrate them with the organization? And that's obviously something that we can't simply, these are things that you wouldn't buy off the shelf because they're too small to do so. And so this is where the power of that continuous integration really comes in, that it's about these small marginal gains that really build up over time until you have something that's really irreplaceable in terms of the capability that it provides. But I might turn to Serena. Could you say a bit more about the tools that the Multiple Benefits Project will be exploring?
So we've got a range of tools. So we're looking at that decision-making space and landscape as well. So we're, on one hand, we're looking at developing a multiple benefits framework, which tries to, I guess, essentially an assessment tool that tries to identify the broad range of not just economic, but also social, cultural, and environmental values all together in one framework. There's also, so we're working with the University of Melbourne, and they're developing an evaluation tool that is, it's essentially a rapid inundation model that is an emulator of a hydrodynamic model that will be able to assess different delivery strategies and the potential outcomes of those in terms of those multiple benefits. And another prototype we are developing that's through with the University of Melbourne research. There's a control systems prototype to see how those multiple benefits can be achieved using real-time data. So how those flows will be actually implemented in deliveries.
Great. Yeah, I'm quite excited by seeing how these new tools will integrate with our partners. And the fact that we're working closely together, I think has a lot going for it. There's a question around what are the elements required to enable successful implementation of the Tech Accelerator? What are the greatest challenges for successful implementation of the Tech Accelerator concept? And what's the potential reward if this can work? And another one also related to frameworks or processes in mind to manage ongoing monitoring and evaluation, given that continuous innovation requires that. So my initial reaction to that is, as part of this presentation, I did mention a couple of elements that I think are important, kind of from a technical perspective, around that access to real-world data, well-defined assessment frameworks, efficient onboarding and training as part of it. If we think one order further away from that, what we're really talking about is getting people on the same page and having things formalized in particular ways. And so part of the journey there is deciding, well, what monitoring and evaluation actually works given where the organization is at a particular point in time. I might ask both of you, but Sam first, do you have any further thoughts on what are the challenges and what enables successful tech accelerator?
Yeah, I was just reflecting on that question and thinking if I could solve everyone's problems with an answer, that wouldn't that be great? But unfortunately, I can't. So, but what I can do is maybe talk about the heuristics that kind of guide some of the discussions that we take to this. So, taking a step back from, sort of what was on that slide. So, measure of success really boils down to the simple equation, or we'd like to think it's a simple equation. It's actually integration over entropy. So, really, you try to get everyone on the same page in the best and most efficient way possible, really, whether that's through codified frameworks for working on things, common data platforms, or sort of standardized approaches to things. And then also you look at the entropy side of the puzzle too. So just because you simplify things doesn't mean you're guaranteed success unless you can also try to reduce friction where possible, right? Looking at how you structure agreements and so data licensing agreements, that sort of stuff. So you're trying to reduce the friction, but also trying to get everyone on the same page. And if you can do that, whatever framework you eventually adopt for your own needs, you're kind of getting yourself increasing the odds that what you're undertaking you will be successful in. So as a heuristic, that's really guided a lot of our decision making, and hopefully it's valuable to you too.
Thanks, Sam. Yeah, I think it's very important to have that broader framing of thinking about, well, what is it that you're building? Which part of the tech accelerator are you furthering at any point? So there's that continuous improvement of the tech accelerator, targeting those friction points and so on. Serena, I wanted to frame the little question a little bit differently for you in terms of how do you see the multiple benefits project tackling tracking of their progress over time, so the monitoring and evaluation, getting people on the same page within a project that involves quite a lot of different partners?
Yeah, that's a good question. And it's a part of that is really trying to get everyone on board in coming up with a shared vision for the project team and all our partners. And within each organisation, they've got their different objectives, but I think overall, we've all got this vision of having better water management deliveries that achieve multiple benefits. And how we achieve that, that's what we're hoping to tackle in some ways in this project, and understanding not only the tools that might be required, but also what other enabling conditions are required for this. So including the governance arrangements, the organisational arrangements as well. So trying to understand how operators are restricted or enabled to make certain decisions that achieve those multiple benefits. So I guess in a way, it's sort of trying to understand what that final vision is and knowing what those indicators are, trying to track towards it. It is a bit of a challenge, but I think it involves a lot of adaptive learning, making sure that we're on the right pathway towards that.
Thanks, Serene. We've got a couple of more specific questions. There's one around that somebody might have answered it already.
May have answered that one. Talking about the measurement uncertainty one?
Yes. So talking about measurement uncertainty, what effect does it have? Sam, do you want to elaborate on your reply to that question?
Yeah, look, it's got a huge impact, because if you want to trust what these things are telling you, the single most important thing is actually accuracy. So if your measurement accuracy is out by like 10, 15, 20%, you're always going to be second guessing sort of outcomes. So certainly has a huge bearing. Luckily in Australia, everyone's kind of pivoting towards plus minus 5% as best practice in situ. That's been super helpful, particularly from an irrigation district perspective. So yeah, absolutely, it's a huge factor. But in Australia, there seems to be quite a bit of movement to get there. And the other thing I'll add is you can still optimize measurement accuracy by finding out the root cause for your uncertainty, essentially. So if you've got values that don't sort of correlate to real life observations, you can either scale up your observations to work out where your inaccuracies are coming from, do an RCA, and eliminate that at source. So we spend a lot of time looking at measurement accuracy, and that's because that's super important.
Absolutely. There's another question around the role of AI in this context. Serena, do you have any thoughts on AI and how it relates to the methods you're using?
I guess AI has its place for answering some questions, but I think we aren't probably in that position to be able to rely completely on AI. We've talked a lot about the importance of the human component in decision making, and so I think we're not at that. I wouldn't be comfortable in relying on AI on its own, but perhaps using it as a tool to support decision making, but also understanding the other contexts around it as well at the same time.
Yeah, what I emphasized in my presentation was that idea about the human in the loop, in particular. I think the way I see it is that AI is a potential tool in our belt, but we don't necessarily need complex methods that are computationally expensive in order to answer the questions that we actually want to tackle. On the other hand, we do want a context in which, even if we have a black box solution like that of an AI solution, we want to be able to assess how does this actually perform. So that clear, well-defined assessment framework becomes even more important in AI where it's a black box. Exactly. Sam, did you want to comment?
Yeah, look, by itself, you're always going to look at the output from an AI-based tool and say, well, how can I really trust that? This is where that integrated approach really adds value, right? So if you go back to, sort of a process that you've got control systems for, you've got objective functions that you're trying to deliver for, it's a much kinder environment for AI to operate in, because you've put guardrails and you've got interlocks, you've got, trips and other fail safes built into your platform. So in that environment, I think AI is a tremendous shortcut, really. And the other thing as well that I think is not explored enough is we all tend to view the world as we are, right? And the current state of our sector really is about more physics-based, physics-based tools and modeling and stuff. AI can give you a really, really good shortcut to sort of, if you look at optimizing your physics-based toolkit, but honing in on where you should be optimizing using AI, using statistical analysis, different forms of machine learning. They've all got their place. It's really around application. And it comes back to the first couple of points I made, really, is that relentless questioning and creativity, because you can really get a long way towards your objectives by leveraging the power of AI.
Thanks, Sam. There's an important question that's been raised also of how these innovations can help large irrigation systems in resource-poor countries. Are these even viable for them? And I think this partly comes back to the question we had earlier around the costs of taking this approach. I think the important thing in a resource-poor context is to start with what you've got with the right mindset in play. So it's already a human in the loop situation. You're probably in a situation where there's a lot of manual operation involved. And so the mindset is to then think about, well, when we develop something, can we take this performance monitoring and evaluation oriented approach to it, and to look at the low-hanging fruit first. So we do live in a condition where there's abundance of information, even in those contexts around remote sensing and so on. What are the low-hanging fruits to be able to test new tools around this space? There's been lots of work done on use of mobile phones and so on in irrigation districts and so on. So I'd say it's firstly about that mindset around the continuous innovation first, rather than simply about one-off adoption of specific solutions. I suppose, Sam in particular, do you have any thoughts around what would you be doing differently if you were to resource-poor area?
Look, continuous innovation in a resource-poor area is actually worth more, really, to further you towards your objectives. It also comes down to how you want to invest your limited pool of resources. Do you need lots of data from lots of instruments, or how does that relate to kind of things like levels of service and so on and so forth? So I'd argue that the value of creativity is actually really, really high when you're resource constrained. But the other thing I'd also argue is, we always look at constraints as a bad thing. It's not necessarily a bad thing. It's just a thing, right? And when you have a constraint, you somehow tend to find a more creative solution to actually solve it. I actually come from India, so I'm also familiar with the creativity in solving problems without a lot at your disposal. And I think that if you really challenge yourself, you might be surprised by what you find.
Thanks, Sam. Love the positivity there. Maybe as a last question to you, Serena, what would you like water delivery to look like in 10 years' time?
Thanks, Joseph. Well, I guess for me, it would be great to see water delivered across the basin in ways that satisfy as many users and communities as possible, so that we have healthy waterways and thriving communities, so including First Nation communities who are given more voice in water deliveries or water management more generally. So it would be great to have system operators having a lot more confidence in the outcomes of their deliveries beforehand. So, many of the operators, they're incredibly skilled and knowledgeable and experienced, but they're faced with a huge range of uncertainties around water availability, demand, transmission losses, and the outcomes of their delivery options. So although we can't eliminate all these uncertainties, it would be great to be reduced as much as possible. So this could be in the form of having access to tools and information that allow them to assess the different benefits and disbenefits of the various options, and so that operators can understand how deliveries will deliveries will affect different users and understand how they can improve outcomes for other users. So in the 10 years, I would like to see water system operators be able to make informed decisions that generate environmental, economic, cultural, and social benefits.
Fantastic. Thank you very much, Serena. And thanks to both our panelists, Sam and Serena. So thank you very much for attending. Hopefully you've enjoyed it as much as I have. The recording link will be emailed to you and uploaded to the website and YouTube channel. And as a live attendee, you'll receive a certificate of attendance that might count towards continued professional development hours. A short 1-minute survey will pop up. So please do complete it. I've emphasized those feedback loops a lot. So we do greatly appreciate your feedback on things. And hopefully you did enjoy the webinar today. I did want to advertise, and please join us for the next One Basin webinar next month as well. Thank you very much.